In society, we really do respect science. In fact, there's actually two legs of physics. One is modern physics. The other is quantum physics. Now, when you take a look at these two, they behave very differently. And we've talked about quantum physics before and how oddly or irrational quantum physics seems to behave. It seems like modern physics should be very straightforward, very understandable, very concrete and practical. But there's certain things that still boggle the mind in modern physics. Take, for instance, time dilation. If you have two identical clocks, you place one on the Earth and one on a plane. This plane goes 600 miles an hour, and it races around for hours in the air as fast as it can go, and then it lands. Once you take a look at those two clocks, the one that was moving in the plane is nanoseconds younger. Now, this isn't some trick or effect of motion. Physics is saying that all frames of reference are just as valid for things that are in uniform motion. But if these things are not in uniform motion, then that frame of reference cannot keep time the same way as the other. This is interesting because this is saying that time is not some solid structural thing. It's based on our perspective. It's based on our frame of reference. That's how elusive time is. But time, in modern physics, still does move in a very linear and logical fashion. This is not how quantum physics works, the whole other leg of physics. Quantum physics seems far more irrational. Now let's take a look at what Stuart Hameroff, a quantum theorist, has to say on The Real What the Bleep with Regina Meredith.
Well, first of all, to explain quantum mechanics or quantum theory, in a general sense, our world is really described by two sets of laws. You might almost say there are two worlds. There's the classical everyday world where things are definite, and there's the quantum world at small scales, although exactly how small is unclear, where things are quite indefinite, and things can be in two or more places at the same time, separated from themselves. Things can be interconnected over great distances and seemingly together even when they're separated, and things can condense into one object. These are all, and time doesn't flow. These are all characteristics of the quantum world. And the classical world, as I said, is definite. I think in a very general sense, the subconscious, our dream world, the kind of situation you described, relates to the quantum world, and our consciousness is actually the transition between that quantum world and the classical world. So it's kind of a boundary between, consciousness exists on the boundary between the quantum world and the classical world.
The quantum realm boggles the mind, not quite rational. So this is why focusing on science is very crucial, but also understanding the limitations of our mind, the limitations of what we can conceive of, is very crucial. Because really what science is experiments that are set up in a unique way, which acts as a lens to let data through certain constraints. So all experiments are lenses for data to come through. But what happens on the other end of that lens, when somebody observes data coming through a scientific experiment, what then happens? The data doesn't just sit there doing nothing. No, we draw meaning and philosophy from the data. That's the next part of it. But the interesting thing is now this is no longer the domain of the scientist within us. It's the philosopher within us that draws meaning from the experiences that we have. Our perceptions have a huge impact on who and what we are and how much potential we can bring to the moment. So this isn't a light matter.